What's up, math scholars? It's a rainy day where I am, but I hope you're having a sunny day where you are. We are about to learn 10.2, day 2. Have those unit circles handy. Who's excited? My live audience is super pumped. All right, so today we're going to focus more on what happens when there's a negative a value out front. Do you have any guesses? What would a negative a value out front cause to happen, live audience? He doesn't know. It flips the graph upside down. It flips the graph upside down. Think back when we did parabolas, for example. A negative out front flips the graph upside down. So we're going to do a couple of quick sketches just to have a visual on what a sine graph would do. An upside down sine graph would be a valley first, then a mountain, since it's normally a mountain and then a valley. An upside down cosine graph would start low, then make a mountain peak, then end low. I'm only graphing one period of each, of course. And then a tangent graph would actually start high, come through the origin, and end low. So that's what your upside down graphs look like when they have negative a values. This is just a refresher from the other day, how scale changes are applied and how translations are applied. We will need that information very shortly. Let's try this first problem. Our a value is the -2, so this is going to have an upside down flip appearance to it. The b value is 2/3. Let's go ahead and figure out the period. Period is 2 pi over b, or 2 pi over 2/3. Do you remember how to divide by a fraction? You multiply by the reciprocal. So this ends up having a period of 3 pi. It's pretty cool. The amplitude will be 2, just the absolute value of a. And then my c value is this 3 pi over 4. It's actually going to end up being a right shift. So I'll be adding 3 pi over 4 to all my x values to shift it to the right. We'll have fancy common denominators like we had the other day. Maybe it was even yesterday. Can't remember. All right, so let's do our key points of a sine graph. 0, pi over 2, pi, 3 pi over 2, and 2 pi. What is the sign at 0? 0. What's the sign at pi over 2? 1. What's the sign at pi? 0. And the sign at 3 pi over 2? -1. And then we're back to 0. So those are my key points. Those don't get graphs because we do have to do the scale change and the translation still. We're going to do that scale change first. The scale change formula from the previous page, I'll just write it up in case you've forgotten, is 1 over b times x, and then a times y. Now 1 over b is kind of crazy. It's 1 over 2/3. 1 over 2/3, you'd multiply by the reciprocal, so it would just be 3/2. So I'm going to be taking 3/2 times all my x values. And I'll be taking -2 times all my y values. Let's apply these changes, the scale change in our first column. All right, so let's multiply all our x values by the 3 over 2. This would still be a 0. Pi over 2 times 3 over 2 is 3 pi. No, wait, I messed that up. Pi over 2 times 3 pi over 2. Wait, pi over 2 times 3 over 2, I don't know why I'm having a brain cramp, is 3 pi over 4. That's looking better. Man, having trouble thinking today. Okay. Pi over 2, sorry, I should just start myself over. 3 over 2 times pi is 3 pi over 2. 3 pi over 2 times 3/2 is 9 pi over 4. I think I do better if I write my work down below. And then 2 pi times 3 over 2 is 6 pi over 2, which that reduces to 3 pi, which makes sense because I had said earlier my period was 3 pi. All right, we're good. I'm going to erase these stray marks. That was just me doing my thinking. I need that space down there for my common denominators coming soon. All my y values get multiplied by -2, so that's quick and easy. I don't need to do that work down below. And now it's time to do my translation. My translation is just a right 3 pi over 4 translation. So all my x values, I will add a 3 pi over 4 to them. All my y values are going to stay the same because there's no vertical shift on this graph. So let's just keep all my vertical numbers the same, all my y values the same. And now we have to do some adding. All of our x values, we will add 3 pi over 4. So adding that to a 0 is easy. If I take my next x value, which is 3 pi over 4, and I add 3 pi over 4, it is 6 pi over 4. Do you guys want to reduce that down? 3 pi over 2. Divide the top and bottom by 2. My next addition is 3 pi over 2 plus 3 pi over 4. I'm going to need a common denominator of 4. So multiply the top by 2. 6 pi over 4 plus 3 pi over 4 is 9 pi over 4. My next addition is a 9 pi over 4 plus 3 pi over 4. That's 12 pi over 4, and let's reduce that down. Divide the top and bottom by 4. So 3 pi. And finally, I have to take my 3 pi and add a 3 pi over 4. Let's get a common denominator of 4. Multiply the top by 4, get 12 pi. So I think we're looking at 15 pi over 4. All right, let's do our best we can with graphing. I think when I graphed this, I just left the numbering how Mrs. MacDonald had it, the pi and the 2 pi and the 3 pi and the 4 pi. It's a little blurry, but that's a pi right there. And then a 2 pi, and then a 3 pi, and then a 4 pi. It's just so small, it's blurry. So at 3 pi over 4, that's basically 3/4 of a pi. We're at 0, about there. At 3 pi over 2, that's a pi and a half. I'm at -2 right here. At 9 pi over 4, that's a little over 2 pi. I'm at 0. At 3 pi, I'm up at 2, right there on the grid. And at 5 pi over 4, which is just less than 4, I'm at 0. So that's my 1 period. You can see it's an upside down sine graph because of that -2 out front. Our domain is what it's always been, negative an infinity to an infinity, but it looks like our range is from -2 to 2 on this one. Okay. We're going to do 2 more graphs because I realize these graphs just take so long, so we're only going to do 2 more. Our next one's actually going to be a tangent graph. We'll save these for in-class Q&A sessions. So just a quick review of tangent graphs. You have a different period formula on tangent graphs. Your period formula is pi over the absolute value of b. Let's identify our a and b, shall we? A is 2, b is pi. So my period would be pi over pi or 1. Now just a reminder, from this asymptote to this asymptote, that has to have a distance of 1. So I would label this at positive a half, this at negative a half, so the whole entire distance could be 1. Now we'll talk halfway points. Halfway to 1/2 is 1/4. Halfway to negative a half is negative a fourth. Now if you remember, our halfway points are gonna be at 1/4 comma a, and our a value is 2, and negative 1/4 negative a value. So I'll go up to 2. I'll go down to -2, and then I cross through 0, 0, because all tangent graphs do. And that's our tangent graph. Now we reviewed the tangent graph because you can probably guess what we're about to do. Flip a tangent graph upside down. So here's our tangent graph. We're not only going to flip it upside down, that's what the a will cause to happen, but we are actually going to shift it up. Shift it up. So you'll basically just be adding 5 to your halfway points to shift everything up. Instead of going through 0, 0, it'll be going through 0, 5. I can put that on there right now. All right, so let's figure out our period. Our period's pi over b. Do you guys know what the b value is? An invisible 1. So it's just pi. So I need my distance from this asymptote to be pi units. So this would be at half a pi, or pi over 2, and this would be at negative pi over 2. The halfway point would be pi over 4 and negative pi over 4. Now, normally, you're at the halfway point, pi over 4 comma a, but this time, a is a negative number. So it's going to be pi over 4 negative 3 as the halfway point. Down here. Oh, I'm sorry, I forgot the up 5 shift. I have to add my 5, so my halfway point gets shifted up, so it's pi over 4 comma 2. There we are, 1, 2. That'll cause the upside down graph that I was expecting. And then our negative halfway point, negative pi over 4 comma negative a 3, but we'll add 5 to it because that up shift. So negative pi over 4 comma 8 would be up here, and there's that upside down tangent graph. Okay. So I did that up 5 shift on both my halfway points. Here's my halfway points. The period, just to answer all the questions at the bottom, was pi. Horizontal shift was none. Vertical shift was up 5. Here's my halfway points. And then my asymptotes are at x equals pi over 2 and x equals negative pi over 2. Thanks for watching this short video today. It's only 11 minutes. We are definitely going to be doing some more practice problems in our live Q&A when the class is joining me, just to practice more of these shifts and these key points. I know it gets kind of difficult with the common denominators and things like that. So thanks for watching the video.